All right, so in this case, we are going to consider our April 2024 exam, which is actually the paper that we wrote in March 27, which is 2024. So we are going to see, guys, how we're supposed to attempt these typical exam questions that we were given. So remember your instructions, make sure that you read each and every part that you are given so that you'll be able to attempt these typical questions properly as instructed on the instructions. So we're not going to waste much time. Let us quickly rush through our questions. That is question number 1.1, we are given make n the subject of the formula. So in this case, we are given this equation, and from this, we are supposed to make n the subject of the formula. All right, so in this case, guys, I'm just going to try and work out on this space. That is 1.1. We're given that t is equal to mr minus, all right, so this is minus nr, everything over m and e like this. Okay, so from this, we are supposed to make n the subject. This is where we have got n, and also there is n on this part. So you're supposed to make n the subject of the formula. How can we do this? That is the question. So in this case, we have got a fraction. So considering that we have got a fraction, what we need is to get rid of the fraction. T is same as t over 1. So meaning to say we can cross multiply in this case to get rid of the fraction. That means t is going to multiply m and e, that is t m and e is equal to 1 times this part. So 1 is going to, remember, 1 times any number, it remains as it is. So that will be mr minus nr. So take note, we have got the capital letter and the small letter r. What we need is n, but as you can consider, there is n on this side, there's also n on this side. So what are we supposed to do is to collect the terms with n to one side of the equation. So I can transpose this term to the other side of the equation. That will be a positive. So we've got t, m, and e. If this is taken to the left side, it's going to be a positive. So that's nr, which is equal to mr. So we have got the terms of n on one side of the equation. What's the purpose of doing this? So that we can factor out that common term. We can factor out the common term. And what is our common term? The common term that we want is n. We are considering our common term, which is n. So factor out n, you remain with t, m, e. Remember to factor out, you're going to divide. So this n and n cancels. You remain with t, m, e plus nr divides with n. So if this divides, you're going to remain with r. So that is r, which is equal to mr. So as you can see, we have got the n, and this n is multiplying this bracket. So what are we going to do? We are going to divide by the bracket to remove this bracket, which is being multiplied. So we divide by this bracket of TMA plus R, divide by this, that is TMA plus R. So this is going to give us the n that we need. So therefore, our n is equal to this part that we are given, which is MR over TME plus R. So this is how we can simplify this. This is a small letter, guys. This is a small letter r that we are having there. Why am I getting the capital letter? This one. This one is the small letter. The capital letter is this one on top. This one, we are working with a small letter. So you're supposed to maintain the letters the way they are given. All right, so that was how you're supposed to attempt this question. 1.2. Solve the equation, the following equation, by using the quadratic formula. And we've got 4 marks for that. All right, from this equation that you're given, that is 1.2, you're given 3r squared plus 1 is equal to 4r. So if you're to consider, remember what we need is the normal ax squared plus bx plus c, the one that we are used to as our equation. Then we use x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Remember your quadratic formula. Also, you have got from a formula sheet. So if you are to consider, it is important that you have the order first, which is the format ax squared plus bx plus c. So in this case, we're supposed to transpose this to the other side of the equation so that we remain with a 0. So that's minus 4r plus 1 is equal to 0. We have got the equation that we are used to in the format that we are used to. So in this case, what is representing a, b, and c? So our a, the coefficient of the x squared, which is the coefficient of r squared. So our a is 3. B, the coefficient of x, which is the coefficient of r in this case. That's our b, which is minus 4. And c is the constant, which is 1. So if you had to use the formula, this time it's r, not x. There is r, not x. So meaning to say r is equal to minus b, which is minus our b, that is minus 4, plus or minus the square root of b squared, our b, that is minus 4 squared, minus 4 times a, which is 3, times c, which is our constant. So this is everything over 2 times a, which is 3. So that is how we're supposed to attempt this question. So if you're to consider, yes, we can simplify the minus and the minus, that's a plus. So that will be 4 plus or minus the square root of, just simplify everything here inside of the square root. You were going to obtain a positive form. That is over 2 times 3, which is 6. So considering you can determine the square root of 4, or you can just use a calculator at once to determine the values of r. You're going to obtain 1 for a positive, for a negative, r was going to be 1 over 3. So you can just simplify direct from the calculator. So that's the quadratic formula, guys, for you. You must be able to use the formula, take the values properly that you are given, then from there, substitute into the calculator the values that you're given. So that was a 1.2. 1.3, solve for m and n in the following simultaneous equations. So we are given 2 equations that you're supposed to solve simultaneously in this case. All right, so that was our question 1.3, where we are given 4m is equal to 8n plus 20. And the other equation, 6n is equal to 70 plus 7m. All right, so these are 2 equations that you're working with. You can consider this as equation 1 and this as our equation 2. All right, depending with the side that you're going with, the equation that you're going to work with and the method that you're going to use. All right, so in this case, I'm going to choose the substitution method. From the equation 1, it's easier for me to make m the subject. All right, so from equation 1, so I'm going to work from equation 1. I'm going to make m the subject. 4m is equal to 8n plus 20. So there we are using the substitution method. Okay, so considering the substitution method, so you choose the method of your choice. So as you can see from this equation, it's easier for us to make m the subject. What you just need is to divide by this m. It's a product. So you're going to divide by m, divide by m, divide by m. That means our m is equal to, that is 2n. So you're going to have 2n plus 4 into 20, that is a 5. So this equation that we are having in this case, or this part of our equation, is representing m in terms of n. So you can write this as our equation 3. So using the substitution, we're going to take the equation 3 into the equation 2. Remember, you made this from equation 1. So you do not substitute back into the equation 1. You substitute into the other equation. You do not substitute back here. You substitute in the other equation, that is in equation 2. So you're going to substitute in equation 2. So whatever that you have just determined, we are going to substitute it in equation 2. In place of m, we are going to substitute what we are given. So that means 6n is equal to 70 plus 7m. So this is 7 times m. What is representing m is 2n plus 5. So as you can see, we now have an equation that has got only n. So you can solve for n. It's a normal equation that you are used to, expanding of the brackets so that you can solve this equation. What is expanding or affecting this bracket that you are given of 2n plus 5? What is it that is affecting this bracket? That is the plus 7. So we're going to expand by 7. So 6n is equal to 77 times 2. That is going to be 14n. Remember, you distribute throughout 7 times 5, which is 35. Then from there, we can collect the terms with n to one side of the equation. You can even transpose the 14n to this side of the equation. So it will be a minus. So that is 6n minus 14n. We are actually subtracting these two. So 6 minus 14, that is minus 8n. Okay, which is equal to, on this side, you'll be left with 70 and 35. You add these two, that is 105. Remember, you want to find n is a product, divide by -8, by -8 both sides. So thus, we have got the value of n. So in this case, n was going to be -105 over 8, or you can write it as a decimal, which is -13,125. You have to write it as a decimal. It is going to be -13,125. So using the substitution method, we have got the n value, this one that we calculated here, or this one as a fraction, depends with which answer that you want. You can substitute into equation 3 to determine m. Already, m is the subject. So you can take advantage of equation 3. From equation 3, we can substitute, in this case, to find m. So in this case, to find m, we can substitute into equation 3, where m is equal to 2n plus 5. So m is equal to 2 times n, which is the value that you obtained. You can substitute a decimal or that fraction, whatever that you are going to substitute them, plus 5. So thus we've got the value of m. So in this case, if you had to substitute the value of n, m was going to be, as a decimal, that was going to be -21,25, or you can even write it as a fraction, which is -85 over 4. So it was going to give us something like -85 over 4. So you can use any method that you are familiar to, that you are used to. Elimination method, you can use the substitution method, whatever method that you want. Just work with the easier part that is easy to work with. This is exam. Remember, you are wrestling against time also in exam. So choose the easier path. All right, so if you're to consider 1.4, again, it is to solve. And if you're to check this equation, it's a matter of brackets. So what is it that you're supposed to do in this? So you're given -2 into the bracket of 2t plus 6, which is equal to -3 into the bracket of 5 plus 3t. So you can expand the bracket by -2 into the first bracket. -2 times 2t, that is -4t, -2 and +6. That will be a -12. This is equal to -3 times 5, which is -15. Negative and a positive, that will be a -9t. So take note, there's a negative, a positive, so it will be a negative. So you can collect the terms with t to one side of the equation. So this will be a positive. The moment that it crosses the equal sign, it changes its sign. So that's -4t plus 9t is equal to, transpose the -12 to the other side of the equation, it will be a positive. So that's -15 plus 12. Okay, let's add. These are like terms. So you can add -4 plus 9. That was going to be a +5. T is equal to 15 plus 12, which is minus 3. Okay, so from there we can simply divide by 5 by 5. So t is minus 3 over 5. So that is what you're supposed to obtain. Just like that. All right. So that was our first question. And considering question number 2, given the following algebraic expressions, this expression and also this expression combined, we're asked to factorize each completely. All right, so let us consider our algebraic expressions that we are given, and we're asked to factorize each completely from the given information. All right, so let us consider the first algebraic expression that we are given, 5a squared minus 5a minus 5ac plus 5c. If you're to consider in this case, we've got 4 terms, 1, 2, 3, 4. So whenever you're given 4 terms, it is best that you factorize by grouping into 2 terms. From the first 2 terms, what is common between these 2 terms? You factor out that common term. So you can see that factor 5a is the highest common factor. So you factor out 5a, this will divide the 5a squared and the 5a. What are you going to obtain? That will be a minus 5a and 5a, you obtain a 1. Minus 5ac and 5c, what we need is to obtain the same bracket of a minus 1. So what are we supposed to consider in this case? There is a negative, so you can factor out minus c, so that this will be a positive. Remember, minus 5ac divided to this term that you have factored out, minus 5c. This will cancel, and a remains as a positive. But if you consider on the other term, the 5c divided to the minus 5c, that will be a negative. If you consider this will cancel and you remain with a negative 1. So this is what we want. These 2 brackets are common, the a minus 1 and the a minus 1. So you can factor out the common bracket of the a minus 1. So that's a minus 1 into what is remaining. What we are remaining with is 5a minus 5c. So if we are to consider this is not in simplest form. It's true we have factorized and this is in brackets, but it's supposed to be fully factorized or to be factorized completely. To be factorized completely, we are not supposed to obtain anything common in these brackets. Like what we are seeing in the second bracket, 5 is common. 5 is still common. So you're supposed to factor out this 5, which is still common from this bracket, the 5 that is common, we are supposed to factor it out. So we're going to factor out the 5. That means we are going to remain with what? If we factor out 5 in this bracket, that's 5a divided to the 5. You're going to remain with a. Minus 5ac divided to this 5, you're going to remain with minus c. It must be in simplest form. As we can see in this bracket, there's nothing common. In this bracket, there's nothing common. So this is the simplest form that we're supposed to have. So every factorization is supposed to be in simplest form. Every factorization that you have. To factorize completely, that's the instruction. All right. Another part we are given, this is 15a squared minus 30ac plus 15c squared. All right, so let's check this one. That's there we are given 15, that was 15a squared minus 30ac minus 50, it was a positive 15c squared. All right, let us consider, guys, again. That's a positive there, so be careful. There's a positive. So if you are to consider in this case, we can see that this is a normal quadratic expression that we are used to. But in this case, if you consider there's a 15, but what can we do with this? Because you can see that we've got 3 terms, so you cannot factorize by grouping like what we have on when you're given 4 terms. By grouping, it's when you're given 4 terms. You can factorize by grouping. This one, remember your direct factorization of having the 2 brackets. But in that case, it is easier if this is a 1. So what is affecting is the 15. So you can factor out the 15 first. So 15 divided by 15, that will be 1a squared, which is a squared, minus 30 divided by 15, that will be minus 2ac. 15 divided by 15, that will be a plus 1c squared. So it's just c squared. So as you can see, we are used to this type of a factorization where we are going to have two brackets. Remember your quadratic expressions. The coefficient of a squared is a 1. So we are going to have a in the first bracket and a in the second bracket to obtain the a squared. But since this term is c squared, we must find the products of this constant of c squared. And these products must add up to minus 2c. They must add up to minus 2c, the products of c squared. So we need the product of c squared, two terms that you multiply, you obtain c squared. You add those terms, you obtain minus 2c. So the product of c squared, positive c squared, you can multiply c and a c. You can multiply minus c and minus c. But between these two combinations, which one that when you add between the two, you're going to obtain minus 2c? C plus c, that is 2c, not minus 2c. Minus c is equal to minus 2c. So these are the ones that we need, the minus c and the minus c. So you have to consider the term as it is, the last term as it is, the factors of c squared. But they must add up to minus 2c. The a, this one is already affected. When you placed this a, don't refer it back here. It's already considered on this part. Just like our normal terms, 2 times 2 is same as 2 squared. So it is the same consideration if you're given two brackets like this. It is the same as we are given a minus c squared. So this is 15 into a minus c squared. It does not affect even if you just write as the two brackets 15 into a minus c into a minus c. That part does not even affect. So that's to factorize. And from these factorizations that you have made, 2.12, it was to determine the HCF and the LCM of the expressions. Remember the lowest common multiple and HCF concept. All right, so let us start with them. HCF, the highest common factor is the common, the bigger term that you're going to have, but common between these two already factorized. Remember 15 is same as 5 times 3 or 3 times 5. Meaning to say the 5 and the 5 is the common term. So we're going to consider 5. In terms of the brackets, a minus c, there is a minus c, but this is raised to the exponent of 1. Remember, if the bracket is common, you take the one with the smallest exponent. So it is going to be a minus c. So that is 5 into a minus c. A highest common factor has to be common throughout, whereas the multiple is supposed to be every term that is presented. The 5 and the 3 giving us the 15. The 5 we've already taken. If this 5 and this 5 is the same. So 5 times 3, that's 15. You're going to consider the 3. This bracket is of a minus 1 as long it is there, as long you can see that even though it's not common, the multiple consists of all terms. So you must consider that bracket. But in the case of the a minus c and the a minus c, you have to consider where we have got the highest exponent when dealing with the LCM. If the terms or the brackets are common, you take the one with the highest exponent. HCF, the opposite, you take the one with the smallest exponent. So that's the idea there. You've determined your LCM and the HCF, or the HCF and the LCM from that part. All right. 2.2, simplify the following algebraic fractions and factorize your answer completely in any simplification. make sure that your answer is in the factorized manner. All right, so in this case, you were given, just gonna try and work them out here because guys, they've got a lot of things to write here. So the first part you're given, that is 2x squared minus 4x. As you can see, there is a division. This part, this one is a product. So you have to get rid of this division. All right, so that's 2.21. So the first part, you're just gonna write as it is 2x squared minus 4x, everything over x squared plus 6x plus 9, so that you do not forget about this division that you're given there. Just make sure before you do any factorization, rewrite. If you do understand, you can just factorize as you are introducing the multiplication. Remember, division, you must introduce the multiplication, then you tip over the second fraction that it follows after the sign. So x plus 2 is going to be in the numerator, and the 3x squared plus 15x plus 18 in the denominator. So it's a flip. So that is the idea there. All right, so factorize each and every term that you are given. 2x squared minus 4x. What is it that is common in this case? 2x is common. So let's divide 2x squared divided by 2x. The 2 and the 2 cancels. X into x squared. We are going to remain with 1x. Minus 4x when divided by 2x. This one and this one, it's going to be minus 2. X and x cancels. So we remain with minus 2. Everything over what? As you can see, we are back to that quadratic expression that we had before. X squared plus 6x plus 9, considering that the coefficient of x squared is 1, so we're simply going to have two brackets. That's x here, x here. The factors of 9, which is the constant, but these factors of 9 must add up to 6. So we've got 3 and 3. 3 times 3, that's 9. 3 plus 3, that's 6. So meaning to say we're going to have plus 3 plus 3. Okay? Multiplied to, in this case, if you have to consider 3 is common between 3x squared minus 12. So if you have to consider factoring out the 3, this was going to be x squared minus 4. 12 divided by 3, that will be a minus 4. But the x squared minus 4 is a difference of two squares. Remember, a squared minus b squared, which is equal to a minus b into a plus b. We have got the perfect squares, x squared and 4. X is a perfect square. So the square root of x squared, which is x, the square root of 4, which is 2. So you're going to have x minus 2, x plus 2. The other bracket, the other part that you're given, the 3x plus 6, we can see that 3 is common. We can factor out the 3, the highest common factor. That will be x. 6 divided by 3, that will be 2. All right, times already there is an x plus 2 in the numerator. All right, let us consider this other part again, just like the previous part. 3 is common. So if I factor out 3, that will be x squared. 15 divided by 3, that will be 5x. 18 divided by 3, that will be 6. But this part that you're given, if you're to consider, there is a 1 here. So meaning to say that will be something like 3 into the 2 brackets. Remember your quadratic expression, the coefficient of x squared. So also you're going to have x here, x here. The factors of the constant, which is 6, but they must add up to 6. So they must add up to 5. So that's 3 and 2. 3 times 2, that's 6. 3 plus 2, that's a 5. So meaning to say, in this case, we're going to have plus 3 plus 2. So that's it. You factorize each and every term that you're given, or each and every expression that you're given. So now let us consider what is common between the numerator and the denominator. Whatever that is common between the numerator and the denominator, we can cancel. We are considering terms like 3 and 3. This is common. The x plus 2 and the x plus 2, this is common. All right, the x plus 2 here, the x plus 2, this is common. If we are to consider again, we do not have anything common between the numerator to the denominator. We do not have. The relationship that we are just left with is of what is in the numerator only. So what is the relationship of what is in the numerator? You just multiply these two terms. So it's 2x into x minus 2 times x minus 2. So this will be x minus 2 squared. Okay, in the denominator, there's a 3, which is the number. Then we've got the brackets that are remaining of x plus 3, x plus 3, x plus 3. So x plus 3, x plus 3, 3 times. That is x plus 3 to the exponent of 3. So that is what you're going to have at the end. As you can see, there is nothing common that can be cancelled further in this case. Okay, so that was it. That was it, guys. 6 marks for that. All right, if you have to consider 2.22 you're given again to simplify. So let us consider the factorization from these terms that you're given. You can see that we can play around with our factorization between the first term, what is common, the denominator, what is it that you can factor out? So if you have to consider this is m, everything over n is common. N here is the one that is common. So let's factor out n. We are going to remain with mn divided by n. This will cancel. You remain with m minus n squared over n. This will cancel. You remain with n. So it will be minus n plus n over m squared minus mn. So m there is common. If you factor out m, in this case, if we are to factor out m in this part, we are going to divide by m here. So this will be m. You divide by m here. So you remain with n, okay? Plus 1 over n. So the first thing is to factorize. What's the purpose of doing this? So that you can tell the LCD, the LCM of the given denominators that you're given. What is the LCD of these denominators? All right, I talked about the method that you consider that LCD. In this case, this is mn into the bracket of m minus n. Remember, I talked about that. But I also want you to see this other way, which can be actually a way to consider. Okay, I want you to take this way. You know the LCD, there is LCM or the LCD. In this case, there's M and N. N is just common in this case. This N and this N is just the same. So that will be Mn into M minus N. So you do not repeat this part here. And also you do not repeat this M minus N because it is just 1. It is not raised to the exponent of 2. So this is our LCD or LCM. What we need is to make sure that we have got the same LCM here. We need the same term as it is. All right, sorry for that. We need this as it is. So what you're just going to consider is that, all right, here I've got n, m minus n. Any m minus n. So I do not have this m. So what I do not have is the one that I add. I have to consider that what I do not have, so that I have the LCD. I do not have m on this term. To have this LCD, I do not have m. So I'm going to multiply by that m, both the numerator and the denominator. That's another way that you can simplify this question. Okay, you move on to the other term again. You have got m minus n. You have got m minus n, meaning to say we do not have n. What we do not have is n. So you multiply by what you do not have, n over n, to make the LCD. So the moment you multiply this and this, you are now having the LCD. You do the same thing. There is n only, meaning to say we consider only n. So what is it that we do not have? We do not have m and m minus n. So you're going to multiply by m into m minus n. M into m minus n. What's the purpose of doing this, guys? What's the purpose? The moment that the denominators are the same, you just combine your fractions as they are. So this is m times m, which is m squared, plus n times n, which is n squared, plus m into m minus n, as it is this part. Everything over that LCD, because it is the same. If the denominators are the same, as we can see, there is mn, everything that we are is there. So it's going to be that mn over m minus n. That's another way that you can simplify this. Yes, I want you to do that way that we are used to in our simplifications. I want us to see what's gonna be our answer, but let us consider also, guys, learning other ways of simplifying. All right, so in this case, as we can see, we can simplify our numerator, expanding of the brackets of this part so that we can collect our like terms, m squared plus n squared, m and m, that will be m squared. All right, that will be m squared. Guys, where am I getting the n? The n, this is 1 over m, 1 over m. So meaning to say here, guys, this is affected. Very sorry for that. This part is affected here because this is 1 over m, 1 over m. So let us correct this. It was 1 over m. This one over m. So meaning to say we have got the m. What we do not have is the n and the m minus n. You're supposed to multiply by n into m minus n over n into m minus n, like this, okay? So let us multiply 1 times n. So it was going to be n into the bracket of m minus n. Okay, this and this part here is the same. So that is what you're going to have. So let's multiply n times m. That will be mn. N times minus n, that is minus n squared. Everything over mn into m minus n. Okay, so this is it. We can see that the n squared are common, so you can factor out that part. Meaning to say, what are we going to have at the end? We are going to remain with m squared plus mn, everything over mn into the bracket of m minus n. You can factor out the m that is common between these two brackets. So factoring out m squared divided to m, that will be m, mn and m. So if you divide this will cancel and that will be n over mn into m minus n. So do not be tempted to divide these two brackets. There is nothing common there. There's a plus, there's a minus. These two cannot be canceled. But this m and this m can be canceled. It's a product that we are having. So it will be m plus n over, we are remaining with n into m minus n. So this is what you're supposed to have at the end. Just like that. All right, so like I said, you can also consider the other way of after factorizing, in this case, whatever that you had, you can consider the simplification. So of the denominator, remember the denominator concept. So this will be m, we got n minus, sorry for that. Let us consider, this was n. So we got m minus n here, plus, remember, this is n over, we factored m here, and it was m minus n plus 1 over m. So you can actually consider your LCD as it is on this tab. Your LCM, which is, we've got m. So this is just the same m. So you can take it out. N, we also take it, consider it m minus n, same exponent. So that will be just be m minus n. So this is your LCM. So what is that you do? You divide these to the denominator. You divide these to the denominator. Mn, your LCD, into the denominator, this one, which is n into m minus n. So as you can see, this will cancel, this will cancel. You remain with m. That m multiplies the numerator. So it's m times m. So whatever that you divide here, whatever that you get, you multiply to the numerator. So that will be m squared, m times m, m squared. Plus, you do the same thing, the denominator to this. So as you can see, the m and the m cancels. M minus n, you remain with n. So n times n, that will be n squared. M and m, they do cancel. So meaning to say you're going to remain with this. N into m minus n, which is multiplying 2 to 1. And as you know, any number times 1 remains as it is. So this term or expression was just going to remain as it is. If you're to expand your brackets, in this case, because we've got a 1, so that is, I mean, this one, there's no effect. Just consider the n. So n times m, that was going to be mn. N times minus n, that's minus n squared. Everything that you're given is divided to mn over m minus n. So with this, we can simplify further our expressions. The n squared, these terms can cancel. That means you're remaining with m squared plus mn over mn. So this, just like the previous case, we can see that the m is common. So that means you're going to have m plus n over mn. And this will cancel again. Your answer will be this part. Just like what we had, this is m minus, guys. Why am I having this now? You see, these softwares, guys, you'll be writing something while it's not writing. This is m minus n, remember? M minus n there. So there is mn into m minus n. There was mn into m minus n. So this is mn, then you cancel the m, you remain with the n into m minus n. Just the same answer, just like what we got previously. So these are the typical questions that you might be given, and you can even consider different ways, methods, as long it's applicable. As long it's applicable, you can consider any way, as long it's applicable. So that was our question 2.2, which is 6 marks. Question number 3. Simplify the following without using a calculator. The calculator is not required. 3.11. There we are given PQ to the exponent of 1 over 4. So this is same as there's a bracket to the exponent of a 1. So remember the concept of an exponent of an exponent. M to the exponent of A to the exponent of B is same as M to the exponent of AB. Exponent multiplies an exponent. So it's 1 times 1 over 4. So this part is same as we've got PQ to the exponent of 1 over 4. Everything over the same PQ that we are given raised to the exponent of minus 3, but it multiplies the 1 over 4. So it's minus 3 times 1 over 4. So that will be minus 3 over 4. So the exponent and exponent multiplies. But as we can consider the PQ that we have, very sorry for that. This PQ that we have here is just like a single term. So what is it that you consider? Division. Bases which are the same. You subtract the exponents. So that means we've got PQ to the exponent of 1 over 4 minus this exponent, minus 3 over 4. The bases are the same. You are dividing. What are you going to do? Subtract the exponents. So this is exactly what is happening. 1 over 4 minus 3 over 4. That was going to be plus 3 over 4. And that will be 1. So it's PQ to the exponent of 1. Remember, any number to the exponent of 1 remains as it is. Any term when raised to the exponent of 1, it just remains as it is. So that is what you're supposed to have for 3 marks. So guys, do revise as much as you can. They were given a logarithm. Simplify this logarithm, the logarithm of a squared plus log b squared over log a to the power 4 plus log b to the power 4. They are exponents. Remember your logarithms, you can drop this exponent. So it'd be 2 log a, drop this exponent to log b, everything over the same concept. In the denominator, there's a 4. That will be 4. Log of A also on B, that will be 4, the log of B. So you can drop the exponents that you're given. The 2 is common in the numerator, so you can factor out the 2. You remain with the logarithm of A plus the logarithm of B, because you can see that there's something fishy there between these two logarithms. If we are to factor out the 4 in the denominator, we are going to remain with the log of A plus the log of B, which is exactly the same as what we had in the numerator. So this will cancel. Also, if you reduce 2 and 4, that will be 1 over 2. So meaning to say that was going to be 1 over 2. The log is no longer there. The log cancelled. We no longer have the log. That is how you can attempt typical questions of that nature. So it can depend with the question that you're given. 3.2, solve the following equations without using a calculator. 3.21, where we are given, that is p to the exponent of 2 over 3. In this case is equal to 9. All right, remember the concept of this removal of this exponent that you're given. The reciprocal of 2 over 3, the inverse of what you're given, 2 over 3. It is just the inverse. You interchange, that will be 3 over 2. If you're given the exponent, like, which is whenever you're given your base, which is the unknown, what you need is to get rid of that rational exponent that you're given. You simply find its reciprocal, the inverse. So what is the inverse of 2 over 3? That is 3 over 2. So meaning to say 9 is raised to the exponent of 3 over 2. So if you have to check 2 over 3 times 3 over 2, this gives us a 1. If you multiply these two, you obtain a 1. So that's p to the exponent of 1 is equal to 9 to the exponent of 3 over 2. So p is equal to what? 9 in the base of 3. Remember, this is same as 3 to the exponent of 2. Raised to the exponent of 3 over 2. Remember what I talked about before, an exponent to an exponent. You multiply. So that's 2 times 3 over 2. This will cancel. So p is equal to 3 to the exponent of what? Of 3. Which is a 27. 3 to the exponent of 3, that's a 27. 3 times 3 times 3, 3 times. Just like that. All right, 3.22, you're given again the same situation. So in this case, you can even write this as p is equal to 1 over p. That is 1 over p, the logarithm of 27 in the base of 3. Just one and the same. How can I get rid of this 1 over p? Actually, the p is in the denominator, so I can just multiply by p here, multiply by p, so this will cancel. So that's p times p is p squared, which is equal, this is cancelled. So I'm left with the logarithm of 27 in the base of 3. Remember simplification of the logarithms. This can be written in the base of 3. How so? P squared is equal to the logarithm of 3 to the exponent of 3 in the base of 3. So remember the idea, drop the exponent. Why are we doing this? What we need is the logarithm of a in the base of a, which is equal to what? This is an exponent, just like what we saw before. The exponent can be used to multiply the logarithm. So this will be 3, the logarithm of 3 in the base of 3, which this is equal to 1. Log a base a is equal to 1. So meaning to say, in this case, our p squared is equal to what? This is 1 times 3. And 1 times 3 is 3. So if p squared is equal to 3, what about p? The square root both sides to remove the square that you're given. This is now a numerical value. You're working with the numerical value now. The log is no longer there because log 3 base 3 is 1. From this log, log a base a is 1. So as you are working with the logarithms, also you must consider your laws of logarithms. Your laws of logarithms. Let's check 3.3. Let's see what we got here. Solve for x using laws of common logarithms. All right, so then we are working with the common logarithms. If this is equal to x, so this whole part that you are given, it is simply 3.3, it is simply x is equal to 64,5 times 3, everything over, this is the 7th root of 182. So make sure that you do watch the videos on the exponents and logarithms. I talked about how to solve these typical questions. In actual sense, they will just ask you to simplify this, but in this case, you're already given as x is equal. They introduce the x for you. So what you're simply going to do is to introduce the logarithms both sides. All right. So introducing the common log both sides, this is the common log both sides. So it means our statement is now the logarithm of x, which is equal to, remember what I said, a product of terms under a log. Where was it taken from? What made us to multiply a and b? It was taken from the addition of log a and log b. So the product of these two terms under a log is an addition, which is fine. What about a division? A division that we are seeing the logarithm of a over b, it means the log of a was subtracting the log of b. So you can consider this as a single term as our a first, this one as a single term. So it means this is going to be the logarithm of 64,5 times 3. It's still a single term. But this is a single term, so we are subtracting the logarithm of the 7th root of 182. So this is what we have. This is what you have now. So let's go back to the product. What made us to multiply? It was because of addition. So meaning to say we have got the log of x, which is equal to the addition of these two. So it is going to be the logarithm of 64,5 plus the logarithm of 3. It must be addition of logarithms. But this raised this, the 7th root of 182. It is the same as what? Remember your laws of exponents this time. X to the exponent of a over b, it is the same as the base root of x to the exponent of a. Or maybe you are just given x to the exponent of 1 over n, which is the nth root of x. The nth root of a number, that's 1 over that number. So meaning to say whatever that we are seeing here is the same as there's a minus logarithm of 182 to the exponent of 1 over 7 to the the nth root to the exponent of 1 over that exponent. So these are logarithms, they are laws. An exponent is not supposed to be written like this. We drop the exponent to multiply the logarithm. So that means we've got the log of x equal to the log of 64,5. That is 64,5 plus the logarithm of 3 minus, you drop this exponent, so that's 1 over 7, the log of 182. All right. So what I want you to do is to simplify and fix your answers to 3 decimal places, or you can choose any other degree of accuracy that is suitable. So you simplify using the calculator, the log of 64,5. So that'll be 1,810 to 3 decimal places. As for me, I just maintained 3 decimal places. The logarithm of 3, it is going to give you 0,477 minus 1 over 7, the log of 182 combined together, this whole part of minus 1 over 7 log 82, it is going to give us a negative 0,323. So that's it. So you combine everything using your calculator on the right-hand side, combine everything. That was going to be 1,964. So remember, what you need is to find x. You use the logarithms, which is true, but at the end, you must get rid of the logarithm to remove that log. You are in the base of 10. If the base is not indicated, it means you are in the base of 10. Remember what I said from the introduction, that the logarithm of A in the base of B, if it is equal to C, it follows that this A here, it is equal to B to the exponent of C. So there we have got X representing our A. So this X that we are seeing here, it is equal to 10, the base, to the exponent of 1,964. So that's your X. So that was going to be approximately 92,045. So that is what you're going to have at the end. So that is how you apply your logarithms. You use logarithms to find something that you could have just used your calculator, but they do not want you to do that. They want you to use logarithms. So make sure that you watch the video on this part so that you do understand much more on the simplification using these logs. So that was our question 3. That was our question 3, 15 marks, everything. All right, let's consider question 4. So question 4, we are given the surface area of a sphere. All right, so if you have to consider the surface area of a sphere, you must also consider your formulas. This is what you have on the sphere, the area of a sphere, which is 4 pi r squared, that is the surface area, and the volume. So you're working with a sphere in this case. So they are saying the surface area of a sphere is given as 6,400 pi square centimeters. Calculate the radius of the sphere. Okay, we saw that this surface area, the same surface area that we are talking about, is given as 4 pi r squared. And we are given that surface area as 6,400 pi, just equate to 4 pi r squared. Solve for r. That's the idea. Divide by 4 pi. Divide by 4 pi. So that was going to cancel. So r squared is equal to the pi, and the pi was going to cancel. Or you can just use your calculator at once. That was going to give you 1,600. What you need is r. So introduce the square root both sides. So that means our r is going to be the square root of 1,600, which is 40. The units, the square root of square centimeters, it's just going to be centimeters. So we consider the units in centimeters. 4.12, calculate the volume of the sphere. That is 2 marks. And we saw that the volume of the sphere from our formula sheet, it is given 4/3 pi r cubed. So if you've forgotten this, consider your formula sheet. So we have got the volume, which is the formula for the volume of a sphere. So that was going to be 4.12. So this was 4.11, guys. All right. That was 4.11. Then you're going to consider 4.12. So let us consider this, the volume of a sphere. So the volume of a sphere, it is given as 4/3 pi r cubed. Already we calculated the radius, so it's just a substitution. 4/3 times pi times the radius to the exponent of 3. That is 40 to the exponent of 3. So that was going to give us 256,000. That's 256,000 over 3 pi. And this is volume measured in cubic units, or you can just write it as a decimal. That is 268,082,573 cubic centimeters. Remember, this is volume. All right. Then the question is on 4.13. There is a student called Mpo. All right. So Mpo, a student, claims that if the surface area of a sphere increases, then the radius will decrease. Is Mpo right or wrong? Do a calculation to motivate your answer. So this was up to you guys. They are saying if the radius is, they're saying if the surface area increases, then the radius decreases. You're going to make a substitution of an increased value. It's up to you. Then you check, is it going to be an increased value or not? Oh, this is what you can do. This is what you can do. You just consider this relationship that you're given here between the surface area and the volume. We don't need even to do any calculations there. So it follows that. Let us consider this. The surface area and this radius, they are directly proportional. This surface area is actually directly proportional to radius squared. What does it mean? Remember, if you're working, okay, it's only that it's another subject, but this is it. When two things are directly proportional, the surface area and the radius being directly proportional to each other, it means as this is increasing, this is also increasing. As this decreases, this also decreases. So for any value of the radius that I'm given here, from any value that I'm given of the radius, it means the surface area is supposed to increase. We can even prove it from that part that we had. If we make this the subject of the formula, divide by 4 pi like this. This is r squared. Then we can consider the square root to determine the radius. The square root, both sides. So the radius, it is simply equal to, so we can simply have this in short. The radius, it is equal to the square root of the surface area over 4 pi. So take any value that you want of the surface area, which is increased from this one. We saw that at 6,400 pi, this value that we had before, the radius that we obtained, it was 40 centimeters. I want you to take any value that you think of. You can just use maybe 6,500. You use that, the square root of 6,500 pi, like that, everything over 4 pi, and see. You're going to have a value which is more than this, which is increased value, not this. So meaning to say, Mpo is wrong. Okay, so in this case, Mpo is wrong because as the area, which is our surface area, as the surface area increases, as the surface area increases, the radius also increases. The radius also increases. So it does not decrease, it increases also. So as this increases, this one also increases, okay? So that is the condition of your question. That was the what you're supposed to have. There is C there, the increases, guys. RC increases. All right, so for 2 marks, I think, guys, that's it. 4.2, the coordinates of the points on a curve are given in the table below. Calculate the area of the irregular shape under the curve. All right, so remember that when working with the area, you're supposed to consider the formula. All right, you're supposed to consider our formula. In this case, that is 4.2. So 4.2, remember that our area is the first ordinate plus the last ordinate over 2. All right, let's just hope I have that. Plus the sum of the remaining ordinates, then you multiply to the distance between. So you're going to consider the first plus last ordinate over 2. Sum of the other ordinates, then you multiply to the distance between those ordinates that you're given. So in this case, what you're given as the first is the 2,5 and the 3. Take note, guys, the x are the ones that are having that common distance. That is 0, 5, 10, 15. There's a difference of 5, 10. So the ordinates, you consider the y, the 2,5, there's a 5, there's the y. Those are the ones that you consider as your ordinates. The x there, they are for the difference between these two, between the x. Remember your graph, between the x, there's a difference of 5 here, a difference of 5, a difference of 5. So the ordinates, the first, you consider 2,5. So that's 2,5 plus the last, which is 3, over 2 plus the sum of the remaining, which has got 5, plus 30, plus 35. You add everything that you are given, plus 20, plus 10, plus 6, you add everything that you have. You multiply to the distance between these ordinates, which is a distance of 5. So that was going to give you the area. All right, so that was going to be 2,175 over 4, or as a decimal, 543.75 square units. So you're considering the area in square units. So this is how it can be like. That is how you can be given these conditions. Just have to consider the question that you are given there. All right. So that was 11 marks on question number 4. Everything on number 4. So you're going to consider our question number 5. What is it that you are supposed to have obtained from this question 5? So question number 5, you are now given 5.1. Given the function, so you got f of x, which is y is equal to x squared minus 4x plus 4. So this is a function that you are given, and its equation is given as this. From this function, the question is 5.11, determine the following: the y-intercept of the function. So remember, for the y-intercept, x must be equal to 0. So if x is equal to 0, you substitute, so y is going to be a 4. In place of x, you substitute a 0, so y is equal to, wherever there is x, so that will be 0 squared minus 4 times 0 plus a 4. So y at that moment was going to be a 4. So that's the y-intercept is given as a 0, 4 as a point. If you are to consider this as a point, that will be a 0, 4. Then the roots of the function. So the roots of the function, these are the solutions. Those are the roots of the function if this y is equal to 0. So these are solutions. If y is equal to 0, you remain with the equation that will be x squared minus 4x plus 4 is equal to 0. So you can solve this by the quadratic formula. You can solve this by factorization method. It's up to you. So in this case, considering the factorization method, the coefficient there of x squared, that's a 1. So meaning to say, we are just going to have our x and our x here. Consider the product factors of 4, but they must add up to a negative 4. So that's negative 2 and negative 2. Negative 2 times negative 2, that's a positive 4. But if you add these two, you're going to obtain a minus 4. That's a minus 2 and a minus 2. So in this case, x is equal to 2. All right, x is equal to 2, or x is equal to 2. You've got two values at the same point. So it means this point that we are seeing of x, which is equal to 2, it is also our turning point. It's a solution, and it's also a turning point. Is the root of the function, and it's also the solution. It is the solution, and it's also the turning point. So that will be as a point, remember, xy. Remember, we use the concept where y is equal to 0. So you're going to see that when you're calculating this value, which is the axis of symmetry of the function, which is the value of x at the turning point, which you can calculate from your formula. Remember, you can use your formula. These are the formulas that you can consider on the graphs if you consider the roots that we talked about from this parabola, which are the solutions, like I said, or the axis of symmetry, minus b over 2a. So for the axis of symmetry, we're going to use x is equal to minus b over 2a. So these are the values which are taken from our function that we are given. X squared minus 4x plus 4 like this. So remember, that is, we've got 1 there. So that's A, B, and C. So meaning to say x is equal to minus b, which is minus our b, that's a negative 4, over 2 times a. Our a is 1. So that was going to give us 2. So the value of x at the axis of symmetry is 2. X is equal to 2. Then the y ordinate of the turning point. Remember what I said? This is the x at the turning point. So if this is the x at the turning point, it means we can obtain the y value at the turning point by substituting the x that you obtained in place of x. So that's 2 squared minus 4 times a 2 in place of x plus a 4. So that is going to give us the y value at the turning point, which is equal to a 0. So the y value at the turning point is equal to 0. So it means our turning point in actual sense, our turning point, x at the turning point is 2, and the y value at the turning point is a 0, because that is the conditions of the turning point. So as you can see, the 0.20, it is also the root of the function. So this type of a function is the one that when you are to sketch it, it has got a turning point where it has a solution or a root. It also has a turning point at that same point. This is the typical type of a function that we are referring to. So the question was to use the axis, the system of axes provided in the addendum attached. Okay, so you're going to use A to draw this graph on the system of axes, indicate all intercepts with the axis and the turning point. These are the most important things to consider. So that is our function f of x. So remember your y-intercept, x-intercept, everything that we had there, we are going to consider that part. All right, let me just try and remove this so that we can have our part of the graph here. All right. So as we can see, we are given already the x values, y values, and the scale 1, 2, and so on. All right, so let's see what we are supposed to have. We're going to indicate what is important. What is important on this graph. You are going to indicate what is important. The y-intercept at 0, 4, that is the y-intercept along the y-axis. That's at 0, 4 along the y-axis. So this is our y-axis, and that is our x-axis along this horizontal axis. This is our x. So we need 0, 4. That is at 4. In the y-axis, you mark the point at 4 in the y-axis, okay? Then another point, the roots, which is the x-intercept, is just a single point at 2, 0. And this point, which is the root, remember, it is also our turning point. As we saw before, it is also our turning point. So it is the root, it is also the turning point of the function. So this is what we had from this function. So if you are to consider according to the information that we have, this is what we have. And this function, it was given, guys, remember your function, it was given f of x, which is y is equal to x squared minus 4x plus 4. So in actual sense, you're supposed to draw from this point to the turning point, then it goes back. But just try to see, okay, what is, if I substitute a 1 in this case, this is 0. What if I substitute a 1 in place of x? That is going to be 1 minus 4 plus 4. 1 is going to be 1. So 1 corresponds with 1 somewhere there, if x is equal to 1. All right, what about if x is equal to 3? You substitute. If x is equal to 3, that means in place of x, you're going to substitute 3. That will be 3 squared, which is 9, minus 4 times 3, which is 12, plus 4. So this will be 13 minus 12, which is 1. So 3 is versus 1. You can also substitute 4. 4 squared, that is 16, minus 4 times 4, which is 16, plus 4. So that will be 0 plus 4, which is 4. So 4 corresponds with 4. At least these points are enough to give you a smoother curve. And you can at least see how the curve is going to be like. As you are to draw this curve, you know it's going to be from this point to this point. It's a curve to this point, and it goes back to just like that. But it's supposed to be a smooth curve as you are joining your points. So you guys, you're supposed to obtain something smooth, a turning point, which is also our root of the solution, our root of the function. something like this. It goes like that. So this is our f of x, just like that. So try to have something smoother like that. And this is our turning point, the y-intercept. The turning point is also the root of the function at what? At the point 2. Just like that. So that was 3 marks to have this function. All right, let's see what else are we given on the other part. On the other part of 5.2, we are now given these two functions, the g of x, which is y is equal to x, and h of x, which is y is equal to minus x. Draw all the graphs, this one and this one, on the same system of axes in A that we used before that we had. So we are going to consider the g of x, which is y is equal to minus x, y is equal to x. So there are two functions that you are given there. The g, which is y is equal to x, and the h, which is y is equal to minus x. So these ones, you can even just have your own table of values. These are straight lines. If you know these graphs, it's fine. But a straight line, remember, what you just need are two or 3 points. But 3 points just for the sake of seeing where there is an error. So you can substitute any 3 possible values on your Cartesian plan of the x values, which are the inputs from -3 up to 5. From -3 up to 5, any value of your choice. Any value of your choice. So I can choose -2, 0, and 2. Any value of a choice. If x is -2, y and x, they are equal. So if x is -2, y is also -2. If x is 0, y is also 0. If x is 2, y is also a 2. So you can mark these points that we have obtained. They are the same. Y and x are the same. -2 versus -2 when x is -2. Y is also -2. So you mark a point. X is -2, y is -2. They meet here, you mark a point. You move on to another point that you have 0 and 0. So it depends with the point that you're given. That's 0 versus 0. 2 versus 2. When x is 2, y is 2 at this point. This is the intersection. So these 3 points that we are given here, if we are to join these 3 points, we are going to obtain a straight line. So you are supposed to use a ruler to join these points that you're given. But in this case, guys, I'm just going to join with this, okay? I'm just going to join from this point. I need 0, 0. I also need this one straight. So if you are to see these points, we're going to be like this. That is what we're going to have at the end. These points, we're going to be something like this, okay? Passing through this 0, 0. So it must pass through the points that you're given and also there at 4, 4 like that. So this is our graph of G. All right, so this is our G, which is given as y is equal to x. All right, we also have the h of x, which is y is equal to minus x. So with the same consideration, but this time for each x value that I'm having, it is going to be multiplied by a negative. Y is equal to minus x. So let's say I choose the same values of x that I had before, -2, 0, and 2. Each value must be multiplied by a negative. So y is going to be when x is -2. So that's -2. X is -2. Minus, that's a positive. Minus times 0, guys, there's nothing like -0. 0 is just a 0. When x is 2, you substitute in place of x. So that's y is equal to minus. In place of x, you substitute 2. So that is -2. So these are the points that you're going to have. -2 versus a 2. When x is -2, y is a positive 2. So these two, they meet somewhere there. Where they meet, you mark a point. -2 versus 2. Another point, it is 0 versus 0, meaning to say that's a 0 here versus 0. 2 versus -2, and x is 2, y is -2. They do meet at a certain point, which is here. So you join just like the previous case. You're going to join these points that you are having. So if you're to join, you're going to have something of this nature, joining these 3 points. So this is the graph of h, which is y is equal to minus x. So that was the question. To draw these two graphs on the same Cartesian plane, on the same axis, that you're given, where the graph of f was originally drawn. That is the idea there. So guys, do not forget that this is your x-axis here, guys. This is your x-axis, this one. All right, let me just try and make it bold. Then the y-axis, this one, all right? That's your y-axis, this one. Do not forget that, all right? So I think it's bold enough that we can see it, x and the y. So that is how we are supposed to have our graphs at the end. All right, let us consider the next part of our question, what we were given. 5.22, read from the graphs in addendum above, which is addendum A, the value or values of x for which f of x is equal to gx. Remember, when two functions are equal, the solutions or the values of x are at the point of intersection. At the point of intersection of the two graphs, where the two graphs intersect, that is where you obtain the values or the value of x. So the question is, are these two functions intersecting? The f of x and the gx, are they intersecting? These two, are they intersecting? That is the question. So if you are to consider these two, they do intersect. This is our f of x, which is the parabola. The gx, which is our straight line. They intersect at this point and also at this point. Where they intersect, what are the x values straight to the x-axis? What is the corresponding value in the x-axis straight to the x-axis? What is the corresponding? So you take this with your ruler straight to the x-axis. What is the corresponding value? So x here is 1, x here is 4. These are the values of x where these two functions do meet. At the point of intersection of the two functions, we saw that the other one was at x is equal to 1, and the other one was at x is equal to 4. 5.23, use the graphs again and the same addendum that you're given above to explain, not to calculate anything, not to state, but to explain why the equation f of x is equal to hx does not have a solution. Why is it that f of x is equal to hx does not have a solution? If we consider f of x is this parabola, h of x is this straight line, these two, they do not meet. There is a gap in between these two functions. Remember, the solution is taken at the point of intersection. So f and h, they do not intersect like what we see f and g. If we see f and if you see properly, they do intersect, but this one does not. It intersects with the g, not with f. So here the reason is that they do not intersect. They do not meet each other. They do not intersect. So thus, they do not intersect. So these two functions, they do not meet. They do not intersect. All right. Given the functions p and this one of q, so the p which is given as y is equal to 1 plus sine x, q 1 minus sine x, from 0 to 180, copy and complete. So to copy and complete, you just substitute the values in degrees in place of x. That is 1 plus the sign where there is x is going to be 0. So you substitute the first one when x is 0 degrees, that was going to be 1. When x is 30, you're going to obtain 3 over 2, which is 1,5. At 90 degrees, that was going to be 2. 1,5, a 1 at 180. So you do the same thing, 1 minus sine x. In place of x, you substitute as 0. So 1 minus sine x. When this is a 0, it's going to be 1, 0,5. That's a 0 there. 0,5 from 1 over 2, which is, that is what you're going to have. Then from this information, 5.32, use the system of axes provided in addendum B attached, not this one that we used before, it's another one, to draw these two graphs. All right, so there we are given something of this nature that you are supposed to use to draw these two graphs. So let us start with the P. So, and also if you're to analyze, this is, how many boxes do we have here? That is 1, 2, 3, 4, 5. So it's like 0, 1, 0, 2, and so on. And these ones is 30, 60, and so on. 30 degrees, these are angles. Okay, let's see. So we are going to consider the px. So this is our px. So we're going to consider this is our px. So that's 0 versus 1, 0 degrees versus 1, and so on. So that's 0 versus 1, 30 versus 1,5, and so on. So that's 0 degrees versus 1. You mark this one. It was 30 versus 1,5. All right, 60 degrees, it's versus 1,866. So this one is an approximation that we're going to have of 60 degrees, 1,86. That's just below 2. Remember, this is like, remember I said 0,1. So it's like 2,9 here. I mean 1,9. So 1,86 just before this value. That's at 60. 90, it was versus 2. 120, it was versus 1,86 again. That value again, approximately somewhere there. 150, it was versus 1,5. And 180, it was versus 1. So this is what you have. And from this, you are going to join. That is your P of X, the function of P in this case. So guys, you're just supposed to have a smooth curve. Something like this. So just okay, it must be at the turning point there. So just make sure yours is smoother, very, very smooth than the one that I'm indicating. Yours is supposed to be smooth. So this is the graph of P. So just gonna call this one PX. Sorry for that. Why is it? Sorry for that. Okay, sorry for that, guys. This is 1 plus the sine of X. Okay. Actually, very sorry for that. Then let us consider the 1 minus sine X. So you're gonna have the same thing. Substitute your values. Sorry. That is on this part here. So we need to just substitute our values here. All right, I need this one. Already we substituted, so it's gonna be these values this time. So you consider these values down here. These are the ones that you're to consider. All right, so that is in this case, we've got 0 versus 1. It's at the same point as that one. So, but you're taking those ones down there. So that was 0 versus 1, same point. 30, it was versus 0, 0,5. 60, it was versus 0,134. Remember, this is 0,134. It's just an approximate somewhere there. 90, it was versus a 0. 90 versus 0, 120 versus 0,134. Again, approximately somewhere there. 150 versus 0,5. That's 0,5. And 180, it was at 1. So that was what we're going to have. And if you had to consider, this was going to be something like this. All right, so you're gonna just have something of this nature. So you must have a smooth curve, guys, as you are drawing. Make sure you've got a smooth curve. So that was going to be our Q, which is y is equal to 1 minus the sine of x. So it's like actually you are formulating like an oval, like a shape. There's a shape. It's like a shape that you're having at the end of the day. But okay, let's see our question. The question is, write down the equation of the axis of symmetry of the shape formed, take note, by drawing both graphs in this on this addendum attached. So as you can see, it's actually a shape that you're seeing there. So the question is, what is going to be the equation of the axis of symmetry? Remember, the axis of symmetry is to divide this shape into two equal parts. You can divide this shape into two equal parts symmetrically this way. On this line, representing the x values, so it's at x is equal to what? At x is equal to 90 degrees. So it can be symmetrical at that point. It can be symmetrical at that point where x is 90 degrees. Or you can consider this being symmetrical. Being symmetrical is to divide the graph into two equal parts. It can divide this graph into two equal parts like this. This line here, it divides the graph into two equal parts. This line passing through 1 in the y-axis. So that's the y value. Y is equal to what? Y is equal to 1. So you can also consider this as y is equal to 1 as your axis of symmetry, as long the line is dividing the shape into two equal parts so that it does not overlap when you cover it. When you cover this half to this half, it does not overlap. Or when you cover this half here on top to this half below, it does not overlap. That is the axis of symmetry. So these are your typical questions. Question number 6, convert 1,35 revolutions 2 degrees, 6.1. These are revolutions. A 1 rev or a revolution is equivalent to 360 degrees. What about 1,35? It is simply multiplying by 360 degrees. So 1,35 is equivalent to more. Whatever that you're going to have, you multiply by 360 degrees, since the answer is needed in degrees. So that was going to be 486 degrees. So this was just a proportion to be considered in this case. On 6.2, we are given the peripheral velocity of a wheel at a diameter. What we are given in this case is the diameter of 3/2, which is same as 1,5 meters. Having a velocity of 36 kilometers per hour. We know that this is supposed to be in meters per second. So what is the equivalent? A meter per second is equal to 3,6 kilometers per hour. So how do we convert this back to meters per second? We divide by 3,6 kilometers per hour. So that will be our answer in meters per second, 10 meters per second. These are the proper units that we are used to this peripheral velocity in meters per second. All right, it's only that I removed the part of the formula sheet that we had. I wanted us to refer back to our formula sheet again so that we can be together. But you're supposed to understand this part. So the question was, how many revolutions does the wheel complete per second? Talking of revolutions per second, revs per second. This is the speed. Revs per second. What is n? Revs per second. You're given the diameter, you're given the velocity. What is it that you can consider to calculate this speed in revs per second? Remember, from your formula sheet, you're given V is equal to pi dn, where this V is the velocity in meters per second, the diameter in meters, and the speed in revs per second. With this formula, we can calculate our speed in revs per second, which is from this formula, simply divide by pi d, both sides by pi d. So that is going to be n. So n is equal to V over pi d. That is n, the speed in revs per second, according to this formula. So what is our speed in meters per second? 10 over pi times the diameter that you're given in meters, 1,5. So make sure the units are converted first to the proper units that are needed on the formula. So that was going to be 2,122 revs per second. So this is our speed in revolutions per second. That is revs per second. And another part, 6.22 per minute. The same speed, but this time per minute. How do you convert revs per second to revs per minute? It means you simply multiply by 60. Remember, 1 minute is 60 seconds. So multiply by 60. That means your answer will be in revs per minute. So that was going to be 127.32 revs per minute. Just like that. All right. So that was our question 6.3. Then let us consider 6.3. A sector is cut off from a circle with a diameter of 21 centimeters. So from there, it is a sector which is cut from a circle that we are given as this is being cut. It is cut from a circle whose diameter is 21. So what is the radius? From this point, what is the radius? So the radius, that's diameter over 2, meaning to say we are going to divide 21 divided by 2. That's 10.5. So the radius of this sector is 10.5 centimeters. Calculate the area of this sector in square centimeters if it subtends an angle of 150 degrees at the center. Remember, from our formulas, this angle theta is supposed to be in radians. So meaning to say we are supposed to make a conversion from the degrees that we are given. What is the conversion that we are going to make? Remember, pi is equal to 180 degrees. Pi is equal to 180 degrees. What about 150 degrees? What is it that you're going to have? So that's 150 over 180 times pi. So that was going to give us the angle in radians, and that was going to be 5/6 pi radians. So this is our angle in radians. With this angle, we can calculate our area. So the formula, we are also given this from your formula sheet. The area of a sector is given as half r squared theta, where r is the radius. So that is the radius, remember, in centimeters, 10.5 times the theta, which is supposed to be in radians. Your theta is supposed to be in radians. That's 5/6 pi, the value in radians. So that was going to give us the area, which is 144.317 square centimeters. This is area, and area is measured in square units. But they are also given a hint. Calculate the area in square centimeters. They're also given that. So that is it. So you have to consider, what are you given? 6.4. The height of a segment, we are given of a segment of a circle. So this is, we are also given the formula which connects the diameter, the height of a segment. So given that this segment, the height is given as 18 centimeters, and the length of the chord, which is x, is 12 centimeters. Calculate on 6.41 the radius of the circle. On the formula is for the diameter, but because of the relationship that we do understand between the radius and the diameter, that's the radius is diameter over 2. You can calculate diameter first. The formula is for the diameter, very true. D is equal to h plus x squared over 4h. You are given this formula. This is relating the diameter to the height and to the length of the chord. So with this formula, we can substitute what you're given. D is equal to h, which is our height, 18 plus x squared, that is 12 squared, over 4 times h, which is 18. So with this, we can determine our D, which is the diameter, and that was going to be 40 centimeters. Sorry for that. I'm answering this. I'm taking the answer from the second one. This is 20 centimeters if you simplify properly. So what is the radius now? Like I said before, the radius is diameter over 2. So that will be 20 divided by 2. So our radius is going to be 10 centimeters at the end. All right, so that is what you are supposed to have obtained. Then the question on 6.42, it is, what happens to the diameter of the circle if the height of the segment and the chord length, which is the length of the chord, are double their original dimensions? Meaning to say, from what we had before, this will double, this will double. What is going to happen with the diameter? So if it is like that, just if you do not understand, like in this case, what's going to happen, because it is something that you are working with a formula, just to substitute. Just to substitute the new condition that you're given. When these are being doubled, the height is to double, that is to multiply by 2. So it means the height will be 18 times 2, which will be 36 centimeters. X, which is our length of the chord, times 2 again, 12 times 2, that will be 24. They are being doubled. So what is going to happen in the dam? Just substitute, because you have already the formula for the dam. The formula that you used for the diameter, D is equal to H plus X squared over 4H. Still the same formula. Our H this time is 36 when being doubled. Our X being 24 when being doubled. Everything over 4 times H. Remember our H, which is 36. So this is going to give us the diameter, and our diameter was going to be 40 centimeters. So we want to compare between this diameter that we are given and the one that we are, because the question is asking you. It's a question. It's a question. What happens to the diameter? What happens? So comparing these two diameters that we have, the first diameter, it was 20. The second diameter is 40. What is the relationship? We can see that it's double of the first one. This D that we are having is 2 times 20 of what we have. So meaning to say the diameter is also going to double in this case. So the diameter, in this case, the diameter will double also. All right, according to what we can see, all these given part that everything that we are given there is doubling. The diameter is a double. I mean, whatever that we had, even the diameter. So that's why I'm saying even the diameter will double also. So these are the conditions that you are given. All right. So that is how our questions might be given as. We just have to consider your typical questions. Make sure that you do answer properly the typical questions that you are given. All right, let's see. Another part, 6.5. So in 6.5, we are given sec. Cosec is given as -5/4. This is a ratio for cosec. Remember, a cosec, it's a reciprocal from a sine. The reciprocal. So it means if I am given this, 1 over this, 1 over is the reciprocal. So 1 over a cosec, it's a sine. So I'm also given what I understand, which is the sine of alpha. And what is the reciprocal of this? 1 over -5/4. That is -4/5, the reciprocal from the cosec. You can use the ratio of a cosec, which is fine, or you can find the reciprocal of what you're given. The reciprocal of a cosec is sine. So you have to find also the reciprocal of this answer. From alpha 180 to 270 degrees, determine the value of this. Without using a calculator, leave your answer as a single fraction. All right. So there we are going to need the triangle to represent this information that we are given. So if you are to consider, we are given this theta that we are to consider, or the alpha that we are to consider, it is taken in which quadrant? From 180 to 270 degrees. This is the quadrant that you're supposed to consider. 0, 90, 180, 270. Remember how you consider your angles. So this is where we have got our 180. This is where we have got our 270 in the third quadrant. That is where we expect this to be. So we're going to draw our triangle, which is a right angle triangle, to represent the conditions of what alpha is going to represent. It's true that this is the angle from there, but you just use the normal angle, the normal acute angle inside there. So from this ratio that you are used to of a sine, remember, it's the SOHCAHTOA concept. That is sine opposite over the hypotenuse. According to this, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So the opposite, that is -4, over the hypotenuse, which is 5. So we do not have this side, which is the adjacent. We can find it. Because what we need at the end, if you consider the sine, the tan, is they adjacent on a tan opposite of adjacent. So there's a need, we are going to need this x, which is our adjacent. We are going to need that. So you have to use our Pythagoras theorem, guys. Calculate the third side. Remember, from the hypotenuse squared, which is equal to a squared plus b squared. You can also consider in terms of r. The resultant, r squared, is equal to x squared plus y squared. R squared is equal to x squared plus y squared. So r is the hypotenuse, which is 5. X is the one that you need to calculate. So that's x squared plus y, which is -4 squared. You can just take it as a positive as it is, that one, or as a negative. Okay, let's hope we're going to be able to finish up, guys, because these softwares, I don't know what they're doing. So this is the 5 squared is going to be 25 is equal to x squared. Square this one, that'll be a positive 16. You can take it to the left-hand side, that'll be a minus. So 25 minus 16, that'll be 9, is equal to x squared. So you can introduce the square root to remove this square. That'll be plus or minus 3. So considering the plus or minus 3, remember x can be positive this side or it can be negative. So due to the side that you're considering, x is supposed to be a negative. So in this case, our answer is supposed to be a negative, the x that you're going to use. All right. So after calculating this, if you actually understand, guys, the 3, 4, 5 concept, those Pythagorean triples, there's no need for you to even use the Pythagoras theorem. You know that if you have given 4, 5, this one must be a 3. 3, 4, 5. If you understand that, there's no need. So what we need is that from this triangle that we have formed, use it to find this solution, the tan of alpha. In this quadrant, what is the tan of alpha minus the sine of alpha? Tan opposite over the adjacent concept. So what is the opposite according to this alpha? The opposite, that is -4, over the adjacent, which is -3. Minus the sine of alpha. Already you have this sine of alpha, that is -4 over 5. So you can even simplify this negative cancels, that's 4 over 3, negative, that's a positive 4 over 5. Guys, at this stage, you can even use your calculator there. There's not even a problem. So that was going to be 32 over 15. All right, just like that. So this is how we can simplify these typical questions. 6.6, we are given in the diagram below, AB is 24 meters, this side AB. DF is given as 36 meters and BE is 80 meters from B to E. Then you're given the angle of 30D FDE, which is 33 degrees, FDE 33 degrees, ACB 30 degrees, which is this one, 30 degrees here. Calculate CD in meters. All right, so let's see, CD. So if we are to analyze our question here, we're going to see that CD is found on the line BC, BE, on this line BE. Along the line BE, B to E, we have got BC, CD, and DE. They make up the line BE. So in this case, if we are to find this CD, it means it is going to be the difference of the BE that we are given, because we are given the whole of this BE, minus this side of BC and also this side of DE. If we remove this and this from the BE, we are going to remain with this part of CD here, because together they add up to that. So you can even write it as an equation. If you do not understand this, BC plus CD plus DE is equal to BE. Then you make the subject of what you want to calculate, CD. So you take this to the other side, this to the other side, there will be negatives. So this is it. So the question is, are we having this? We do not have. Are we having this? We do not have. So we are going to calculate these ones. All right. So sorry, are given BE, we have BC and DE. We do not have. So we need to calculate these two. That is the BE, the BC. So we can consider this triangle, this one that we are having on this side. So using triangle ABC, from this triangle ABC, we can calculate BC. So let's calculate BC first. Calculate BC according to the angle that you are given. That is the opposite side. And this 90 and 30 degrees, these two, they are adjacent to each other. So which ratio uses opposite and adjacent from that soccer tower concept? Opposite, adjacent, that's for tan. So the tan of theta, which is the tan of 30 degrees, is equal to the opposite, which is AB, over the adjacent, which is BC. So you can calculate BC from there, cross multiply BC times tan 30, that's BC. Tan 30 degrees is equal to 24. What you need is BC, so you can divide by the tan of 30 degrees, which is multiplying. So divide by the tan of 30 both sides. So that's, you're going to have BC. 24 divide by tan 30. That is your BC, which was going to be something like 41,569 meters. All right, so you've got BC, this part from B to C. Okay, then again, we are going to calculate DE. So you're going to use this triangle. We calculate DE from this triangle. You can calculate DE. According to 33 degrees, DE is the adjacent. Remember, the angle and the 90 degrees, they are adjacent to each other. The 36 facing the 90 degrees is our hypotenuse. Which part uses the adjacent and the hypotenuse from the soccer tour concept? You see, guys, I just got some code. So okay, let me just try and finish up. So that's our DE. We're gonna consider, like I said, from the soccer tour concept, the soccer cos, adjacent hypotenuse is on cos. So that means the cos of the angle 33 degrees is equal to the adjacent, which is DE that we want to calculate, over what? The hypotenuse, which is 36. So what you need is to calculate DE over 1. So you can cross multiply. That is 1 times DE DE is equal to 36 times cos. That will be 36, the cos of 33 degrees. So that is DE. So in this case, our DE, if we were to multiply, you were going to obtain 30,192. All right, so that's 30,192 in meters. So you have got a DE in this case. All right. So this part is the one that you're going to use just to substitute, because what you wanted, guys, it was the BC and the DE. With this, we can substitute into our into this equation that we have formulated. CD is equal to what? BE, which is the BE that we are given on our diagram, the one that I explained before, which is 80, minus BC. We calculated BC, that is 41,569. Minus DE, we calculated our DE, we got 30,192. So together, this gives us the CD, the remaining piece of the line that you're given, the remaining part. So that was going to be 8,239 meters. So these are the typical questions. Let's try to revise as much as we can. As we can see, that was our total of 100. It's actually possible to do the same thing in the exam, totalize that question paper at 100. It's very, very possible. Let's try that. So we shall try work with more questions. Like I said, just try join membership. By joining membership allows you to have access to other questions that are not limited to anything. So make sure that we join the membership, and that allows us to have more questions as we move on. But for now, that's it, guys. Till we meet again.